Welcome everybody to the topic nuclear chemistry. This topic is for the second semester BSc complementary topic for the botany and zoology students. Now from the name itself it is clear that nuclear chemistry, nuclear means nucleus related. You all know the structure of atom, right? The atom is having a central nucleus and around this nucleus the electrons are revolving around it. So the nucleus is having two things, right? Inside the nucleus there are neutrons and protons. You all know that neutrons are having no charges and having mass 1 unit mass, and the protons are having positive charge, one positive charge and one mass. So the nucleus, inside the nucleus there are neutrons and the protons is having only one charge, positive charge. So the nucleus is having positive charge, plus charge, and outside the nucleus there are electrons revolving around it, and we all know that electrons are having negative charge. So the positive charge inside the nucleus and the negative charge of the outside electrons are cancelled each other, so atom as a whole is neutral. So this topic is based on nuclear chemistry. That is, we all know that some nucleus are radioactive while some other are not radioactive. Why it is like that? The reason for nuclear radioactivity is that some nucleus are unstable, and this unstable nucleus want to get stabilized. How this nucleus can be stabilized? This nucleus can be stabilized by eliminating or irradiating rays from this nucleus. By eliminating this nucleus, radiations from this nucleus, this nucleus will, unstable nucleus will come down to the stable state. That's why some nucleus are radioactive while others are not radioactive. From the periodic table it is clear that from atomic number 83 the nucleus are stable. Below 83 the all nucleus are stable. They are not showing any radioactivity. But from atomic number 83 above 83 the nucleus are unstable, and in order to get stability this unstable nucleus having atomic number greater than 83 will show the radioactivity, or will radioactive rays are eliminated from the nucleus and they come to the stabilized state. So stabilized state. So from how this some nucleus are unstable while some other are stable. Already I told you from atomic number 83 up to 83 the nucleus are stable while above 83 it is unstable. How it is possible? From we have a theory, that is nuclear stability belt, that we will discuss it later in our class, but according to that inside the nucleus then we are having neutrons and protons, right? When the number of neutrons, n, neutrons is represented by small letter n, when the number of neutrons is equal to the number of protons, that is number of neutrons and number of protons inside the nucleus are same. So the n by p ratio, neutron to proton ratio, when is equal to 1 or nearly equal to 1, these nucleus are stable. And so these type of nucleus where number of neutrons and number of protons are almost equal to same, they are stable nucleus and they do not show any radioactivity. But above the atomic number 83, the atoms inside the nucleus, the number of neutrons is greater than number of protons. So their number n is greater than p. So when we are taking the ratio of n by p ratio, n by p, the neutron to proton ratio, it will be exceed or it will be above 1. So that type of nucleus are unstable. So due to instability of the nucleus, some species or some elements are radioactive, and they show radioactivity to come to the stable state. So these are the topics in the syllabus, but this is our first class, so we are studying up to some basic topics of radioactivity. Now coming to the definition of radioactivity. From the definition it is clear that The spontaneous emission, that is without any external force, naturally the spontaneous emission of active radiations from nuclei of unstable atom is called radioactivity. That is, unstable atoms are having or showing radioactivity in order to get stability. In the first step I told you that the nucleus, this is nuclear property. Nucleus in an atom, nucleus is kept inside and the electrons are outside the nucleus. So, inside the nucleus there are protons and neutrons. So, nucleus is a very small thing that is kept inside the electron cloud. So, when there are heat changes or light changes or any chemical reactions, there is nothing happens to this radioactivity. So, radioactivity is a nuclear property. So, the external forces like heat, light, etc. does not affect the radioactivity of an element. So, substances which emits radiations are called radioactive substances. So, radioactivity is a nuclear property and it is not influenced by the external factors like heat, physical state or chemical combination, because this nucleus is kept inside the electron cloud. And the radioactivity, that is I have told you that from atomic number 83, above 83 the atoms are radioactive, and those atoms those are called natural radioactivity, means radioactivity associated with the naturally occurring elements. There is no need for external forces to get radioactivity, that is radioactivity associated naturally occurring elements such as uranium, polonium, radium, etc. are called natural radioactivity. That is spontaneous emission without any external means. That is natural radioactivity, no need for external forces. Now coming to the discovery of radioactivity. Actually, radioactivity was discovered by a French scientist, Henri Becquerel. He was doing some research. Actually, he is not doing some radioactive experiments. He was doing some other experiments, and he found out the radioactivity accidentally. That is, what he has done is, he is doing some experiments with uranium. And after his experiments or his research work, before going home, what he done is, he wrapped this balanced uranium in a black paper. He wrapped this in a black paper, and again for more protection, he wrapped this black paper uranium in aluminum foil and kept inside his drawer. So before that, inside the drawer there was a photographic film was there. He just put the radium aluminum foil wrapped radium inside the drawer and went home. After next day when he came back and he took the radium, and that time he noticed that there was some photographic plate inside the drawer, and it was affected by some radiations, because he noticed some spots inside that plate, some spots. So being a scientist, he thought that there is some reaction happens here because of this photographic film has some spots in it. And inside the drawer there was only radium wrapped in aluminum and black paper wrapped radium, and only this photographic film was inside the drawer. So he thought that there are some unknown rays are emitting, and these unknown rays will penetrate through the black paper and penetrate through this aluminum foil and travel through the air, and it strikes on the photographic film, and thus some spots are formed. From his thought, he discovered the term radioactivity. So Henri Becquerel was the first scientist who discovered the radioactivity. Now coming to the units of radioactivity. The most common units used in radioactivity are Curie. Curie is represented by Ci, capital C and small I, and another one is Becquerel, that is capital B and a small q. Curie is the most commonly used unit of radioactivity. What is a Curie? Curie means when we are taking 1 gram of radioactive element radium, 1 gram of radium, and that 1 gram of radium, that is a radioactive element, right? So it will disintegrate or it will emit some radiations, and that 1 gram of radium eliminates how much disintegrations, and that is equal to 1 Curie. So 1 Curie is approximately the amount of radioactivity emitted by 1 gram of radium, emitted by 1 gram of radium, and that emissions are measured, and it was found that it is equal to 3.7 into 10 raised to 10 disintegrations. So when we are taking 1 gram of radium, it will emit 3.7 into 10 raised to 10 disintegrations, and that is equal to 1 Curie. So 1 Curie is equal to 3.7 into 10 raised to 10 disintegrations per second. The another commonly used unit of radioactivity is becquerel. Becquerel is the SI unit of radioactivity. Now coming to the various types of radioactivity. I have already told you that radioactivity, some unstable nucleus will produce radioactivity or emit rays from the nucleus, and they are trying to come to the more stable state. So how they are coming to the more stable state? They are producing 3 types of radiations: alpha emissions, beta emissions, and gamma emissions. That is, a nucleus will produce alpha rays. Along with this alpha rays, they can produce gamma rays. They can emit gamma rays also. And with beta rays, they can produce gamma rays also. So what is an alpha ray? Actually, alpha ray is not a rays. Alpha ray is having 2 positive charge, 2 plus charges, and it is having 4 units of mass. So alpha ray, alpha is having mass positive charge 2, and in the top we are writing mass 4 mass units. So alpha 2 4. What is the unit atomic number 2? It is the helium atom. That is, alpha part is equivalent to helium, He24. 2 is the atomic number, that is 2 positive charge and 4 mass number. So alpha is equivalent to helium atom. The alpha particle contains 2 neutrons and 2 protons. So 2 positive charge and 4 mass number. 4 mass. Since it is having 4 mass number, it is having higher size. Since it is having higher size, its speed of moving is slower. It is bigger one, so it moves very slowly. Comparing to the light wavelength, comparing to the velocity of light, this alpha particle will move very slowly because it is having higher mass. And I told you alpha particle is having 2 positive charges, 2 plus charges. Since it is having higher charges, 2 positive charges, and when this alpha particle passes through a gas, and when this alpha particle, this 2 plus charge, 2 positive charge particle hits a gas molecule, it will ionize. That is, ions are produced. That is, a positively charged particle hits a gas molecule, ions are produced in that case. So alpha particle is having plus 2 unit charge positive charges, so it is having the highest capacity to ionize the gaseous molecules. Okay, I have told you the 2 points. Alpha particle is heavier, its mass is 4, and because of this heavy its size, its speed is lesser or lower speed comparing to the velocity of light, and it is having 2 positive charges, that is high charges, and so its ionizing power is maximum ionizing power. And comparing to the penetrating power of alpha particle through some paper or some wood or some brick, alpha particle, its size is very big, its velocity is very slower, so its penetrating power is very lower. It is having least penetrating power when we are comparing alpha, beta and gamma rays. So the main characteristics of alpha rays are it is having lesser speed, it is having higher penetrating power, it is having higher ionizing power, and it is having very lower penetrating power also. So these are the main points. We can go to the we can look into the main points once again. Alpha rays are actually not rays, they are alpha particles, and this consists of 2 positive charges and 4 times the heaviest hydrogen atom, that is, it is equivalent to a helium atom, and its velocity is very lower than light. Okay, so its velocity is 1/10 the velocity of light, and these alpha particle ionizes the gas. Its ionizing power is maximum when comparing to these 3 emissions. Now, while striking on some photographic film, it produces luminescence, that is, some spots are produced, it produces luminescence in the photographic film. It is having relatively high size when we are comparing alpha, beta and gamma rays. So it cannot penetrate easily through solid materials, it cannot penetrate easily through some solid materials. So these are the main characteristics of alpha rays. Now coming to the beta emissions. Beta rays are actually nothing but electrons. You all know that electrons are having only 1 negative charge and 0 mass, very low mass. The mass of electron is considered as 9.1 into 10 raised to minus 34. So minus 34 is a very lower or very negligible number. So the mass of electron is considered to be nearly 0, and it is having 1 negative charge. Now you people will wonder why. I have already told you that radioactivity is a nuclear property. Sorry, okay, nuclear property, right? It is from the nucleus, and we know that inside the nucleus we are having a neutrons and protons only, and we know that electrons are revolving around the nucleus, but we told that beta particles or beta rays are nuclear emissions, that is, they are simply electrons. How this electron comes in the nuclear properties from the nucleus? Because we know that inside the nucleus we are having neutron and 1 proton, right? Neutron is having 0 charge and mass number 1. This neutron inside this nucleus get converted into proton. Proton is having 1 charge, 1 plus charge and 1 mass number. So for balancing this equation, the 1 electron is ejected. So the electrons are produced, or beta emissions are produced. How they are produced? By the conversion of neutrons inside the nucleus into a proton. When a neutron is converted into a proton, 1 electron is produced. That is beta rays. So beta rays is nothing but electrons. Beta rays are not a ray, that is, some material particles are there where they are electrons, and they are having very small charge. Mass is nearly equal to 0, very small in size. So since they are very small size, they can move very fastly. So their velocity is higher than that of alpha rays. Alpha rays, the beta particles are having higher velocity. And since it is having only 1, electrons are having negative charge, 1 minus charge, 1 negative charge. So when these beta particles are moving through a gas molecules, when this beta particle hits a gaseous molecule, it will ionize. It has the capacity to ionize the gaseous molecules, and its ionizing power is lesser than that of alpha rays, because alpha rays having 2 positive charges and beta rays is having only 1 negative charge. So its ionizing power is lesser than alpha particle. And comparing to alpha particle, the size of beta particle is very small, so it can move very fast. So a velocity is 10 times faster than alpha particles, and it causes ionization through which they pass, and it is lighter than alpha particles. So these are about beta rays or beta particles. Now coming to gamma rays. Gamma rays are nothing but rays. The gamma rays are nothing but energy. It is a form of energy. It is like a light. It is like a photon. Gamma rays are like a photon or light. So it is a energy actually. It is not a particle. While we are telling alpha particles, beta particles, but gamma rays means it is energy. It is a form of energy. As a secondary, it is similar to X-rays. It is similar to X-rays and its velocity is equal to the velocity of light, and it can ionize air to a very less extent. It can ionize air to a very less extent, and it can penetrate. Since it is equal to light, it can penetrate. Its penetrating power is higher comparing to alpha, beta and gamma rays. So these are the three main rays during radioactivity. This one element, one unstable nucleus will produce alpha, beta and gamma rays in order to get stable state, and these are the properties of these rays. Now from this figure it is very clear that the first one is alpha ray, second one is beta ray, beta particle, and the last one is gamma rays. See, this alpha particle is heavier in size, bigger in size, so it cannot penetrating through the solid material. Beta particle is comparing to this alpha particle, beta particle is smaller in size, so it can penetrate through very easily through solid materials comparing to alpha rays. But gamma rays are form of energy. It is like light or photon of energy. So its penetrating power is maximum through solid materials. Now coming to the classification of radioactivity. Radioactivity is generally classified into two types. We have already discussed that is natural radioactivity and artificial radioactivity. Natural radioactivity means spontaneous emission without any external means, without using any external forces. It is already radioactive. Naturally it is radioactive. Its atomic number will be surely above 83. Unstable molecules. They are having unstable molecules. So radioactivity associated with naturally occurring elements such as uranium, polonium, radium, etc. are called natural radioactivity. That is, spontaneous emission without any external means are called natural radioactivity. The second one is artificial radioactivity. That is, artificially we are made. That is, using some external means or external forces, we are converting some stable nucleus into some unstable nucleus. So they will become radioactive. This is artificial radioactivity. The phenomenon of conversion of a stable nucleus, stable non-radioactive, that is no radiations are produced naturally. So stable conversion of a stable non-radioactive nuclei into a radioactive nuclei is called artificial or induced radioactivity. Induced means by use of external force, we are forcing that nucleus to emit the radiations. That's it. Now artificial or induced radioactivity. We have already told that it is a conversion of a stable non-radioactive nuclide into a radioactive nuclide is called artificial or induced radioactivity. This is newly formed radioactive element undergoes radioactive decay. So this is an example, aluminium 1327, 13 is the atomic number, 27 is the mass number. You all know that when hits with an alpha particle 4-2 helium 2, we will get 15 phosphorus 30 plus a neutron. This compound is the parent nuclei, this is the parent one and this is the daughter one. Now these are the some equations of alpha, beta and gamma radiations. Now what are the main difference between natural and artificial radioactivity? Natural radioactivity is spontaneous, it is found in nature itself, and the nuclei of heavy atom disintegrates on their own according to form slightly lighter and more stable nuclei by emitting alpha, beta and gamma radiations. This natural radioactivity is uncontrolled. We cannot control because we are doing nothing to produce radiations from this naturally occurring radioactive elements. So, this is uncontrolled and hence it cannot be slowed down. It cannot be slowed down or accelerated. It cannot be slowed down or accelerated by any external means. And it is usually shown by heavier elements, that is atomic number above 83, they are naturally unstable nuclei, that is their number of neutrons is greater than number of protons. Because of that, the N by P ratio, that is neutron to proton ratio, will be higher than 1. That is why they are having unstable nucleus, and because of this unstable nucleus, they will emit radiations, alpha, beta, gamma particles, gamma radiations, and trying to get to stable one. So, coming to artificial radioactivity. Artificial radioactivity is not spontaneous, and some atoms have to be bombarded. Some atoms have to be bombarded by fast moving particles like alpha, neutrons, protons, neutrons, etc. And this artificial means, that is we are making that molecule or we are making that nucleus radioactive. So, we can control. So, we can control the speed of bombarding particles and for bringing about the artificial radioactivity. And this artificial radioactivity can be induced even in lighter elements. We can make some lighter elements into radioactive elements by artificial radioactivity. So, these are the main difference between natural and artificial radioactivity. Now, coming to mass defect. What is meant by mass defect? It is the actual isotopic mass of an element is less than the sum of masses of constituent neutrons, protons and electrons. So, this difference is called a mass defect. So, mass defect is equal to calculated isotopic mass minus actual isotopic mass is called a mass defect. So, what is meant by calculated isotopic mass? That is mass of proton plus mass of neutron plus mass of electron. If we are mechanically or if we are calculating, then mass of proton plus mass of neutron plus mass of electron, we will get a value, a definite value. But actual isotopic mass, but actually its isotopic mass will be lesser than the calculated mass, and this difference in mass is called a mass defect. This is usually represented as delta. Delta means a triangle type. Delta M, mass defect, delta M. That is, when a nucleus is formed from individual protons and neutrons, there occurs a loss of mass, and this is called mass defect. This is the definition of mass defect. Now, coming to binding energy. What is meant by binding energy? This is the definition of binding energy. The energy that binds nucleons together in the nucleus is called binding energy. Nucleons means what? Protons and neutrons. So, the energy that binds the nucleons together in the nucleus is called binding energy. In another words, we can tell that binding energy, that it is the energy released in the formation of a nucleus from the constituent nucleons is called binding energy. It is a measure of force that holds the nucleons together. Inside the nucleus, it is a force that holds the nucleons together, and that is called binding energy. Greater the binding energy per nucleon, more stable the nucleus is. So, if the binding energy value is very higher, then that nucleus will be more stable. So, coming to the part, our first class, we have discussed the definition of radioactivity and the discovery of radioactivity. We have discussed the various units of radioactivity and types of radioactivity, that is natural radioactivity and artificial radioactivity. induced artificial radioactivity, and after that we have discussed about mass defect and binding energy. That's all for today's class. I hope you have enjoyed this class, and we can see again with another topic in the next class. Okay, see you. Bye.